welcome all of you. Today we are here for podcast on genetic algorithm in AI. My name is Piyusha Sarvankar from YesBank AIT's KD seat. Let's begin our podcast. These are the contents of our podcast. Objectives. Let's see objectives of our genetic algorithm. The main objective of genetic algorithm in artificial intelligence is to find optimal or near optimal solution to complex problems through a process of natural selection. Optimization. The main goal of a genetic algorithm to find best and near best solution to given problem. It is used to minimize or maximize functions such as cost, time, accuracy, adaptation and learning. Genetic algorithm helps adapt to changing environment and learn from the previous generation. They stimulates a process of natural evolution to improve solution over time. Intelligence search. Genetic algorithm prefers to reboost the that avoids to getting trapped in local minima. Introduction. So let's see the introduction of our genetic algorithm. Genetic algorithm are a class of evolutionary algorithms inspired by natural process of a biological evolution and survival of fittest, introduced by John Hallon in 1960s. Genetic algorithms provide a versatile approach to solving natural inspiration search method. The genetic algorithm is optimization and search technique inspired by process of natural evolution based on Darwin principle of survival of fittest. It is a biological concept such as selection, crossover, and mutation to evaluate a solution gradually. Population-based evolutionary approach. Unlike traditional methods that requires a single solution, genetic algorithms works with a population of multiple candidate solutions at the same time. The applications and importance in AI such as artificial intelligence, robotics and scheduling and so on. Let's move on to the definition of genetic algorithm. A genetic algorithm is a natural inspiration optimization technique in artificial intelligence that is based on the principle of natural selection and genetics. Genetic algorithm is biological process to find out whether the best solution over a successive generation. Each solution is evaluated based on a fittest function. Genetic algorithms are particularly powerful in solving complex, large scales and non-linear problems. This is the flowchart of our genetic algorithm. Let's see one by one. First, start begins the process, define a problem, parameters, and stopping criteria. Crossover. Second is crossover. Combines the genetic information from two parents' chromosomes to create a new offspring. Third, mutation. Randomly alters some genes in a chromosome to maintain diversity and avoid premature conversions. Fourth one is encoding, that is representation. It represents a potential solution as chromosome. For example, as a binary string, fittest evolution. It is a fittest evolution, and last one is replacement. Derives which individual carries the best generation. Let's see principle of genetic algorithm. Selection forms chosen filters individually. Strong survival of fittest, strongest evolution survive to the next generation. Diversity maintenance principle of genetic algorithm. Introduce small random changes for diversity. Best solution exchange exchange information between parents. Let's see importance of genetic algorithm. These are some importance like classification optimization on fields, that provides solution with the classification of given fields. NP-hard problem suitable for NP-hard problem. Exploring explanation, large and complex search engineering AI functions, versatile works in engineering and AI. Global optimization offers global optimization rather than just local search. Large and complex sales search can optimize in large and complex search space. Characteristics of a genetic algorithm. Population-based research, unlike traditional optimization methods that focuses on a single solution, genetic algorithms works on a population of multiple solutions. Fittest-oriented evolution. Each individual in a population is evolved using a fitness function, which determines how good or effective the solution is. Use of genetic operators. Genetic algorithm employs three main genetic operators, that is selection, crossover, and mutation. Types of genetic algorithm: hybrid genetic algorithm, adaptive genetic algorithm, parallel genetic algorithm, simple genetic algorithm, steady state genetic algorithm, and distributive genetic algorithm. It combines the genetic algorithm, other optimization method, adjustive and crossover rates dynamically, runs multiple processes in a parallel, and basic model with selection crossover. Only part of a population is replaced each generation, divides population into smaller subpopulation. Types of genetic algorithms. These are some types as we see previously. Next, move on to the real world problem solved by genetic algorithm. First is robotics, path planning, obstacle avoidance, engineering, circuit designing, and in engineering field, circuit designing, scheduling, and healthcare, in healthcare sector, drug design, medical diagnosis, network design, routing the communication and computer networks. These are techniques to solve the problem using genetic algorithms. First is encoding. Every possible solution to problem is represented as a chromosome, usually in the form of a binary string, real number, vector, or other structure format. Fittest function. The fittest function evaluates how good or effective each solution is. Third one is selection. The selection technique choose fittest individual from current population to create next generation. Fourth one is a crossover. Crossover is a genetic operator that combines genes of two parents solution to produce new offsprings. Fifth one is mutation. Introduces small random changes in offspring genes. Replacement determines which individual are carried forward to next generation. Let's see the example of genetic algorithm traversing a salesman problem. So we see traversing salesman problems. Each city, a node, and possible roots chromosome, distance, fittest function over the interaction, and genetic algorithm applies crossover and multilation. Problem of definition. The TSP requires finding the shortest possible route that visit each city exactly once and returns to its starting city. Chromosome representation. Each chromosome represented one possible route. For example, A to B, B to C, C to D, and D to A. Initialization population. A set of random routes is generated at a start to form initial population. Fittest function. A fittest is a fitness is calculated as inverse of a total route distance. Let's see features of genetic algorithm. The features of genetic algorithm are: population-based research. Genetic algorithm works on a set of solutions at once, not just a single solution. Fittest function. Each solution is evaluated to determine how good it is. Selection mechanism. Better solutions are chosen to create a next generation. Genetic operators combines and modify solution to explore new possibilities. Global optimization, able to find a near optimal solution and avoid local optima. Parallelizing a natural parallel because multiple solutions are processed at once. Application of genetic algorithms. These are the applications of a genetic algorithm. As you see, example of a TSP, that is a traveling salesman problem. In that, its advantage is can handle non-linear, multimodal, and constraint problems. Second, machine learning and AI. For example, evolving weights of neutral networks reduce computational complexity while improving model performance. Third one is engineering design, aircraft wing design and circuit design. Genetic algorithm helps to find efficient designing and game in AI. Example, evolving strategies for board games like chess, tic-tac-toe, and real-world strategies can discover novel strategies that are not human designed. This is a genetic algorithm of replacement cycle. It includes replacement individual, generated offsprings, evaluate fitness, select for replacement. So new solutions are generated through crossover and integrate top skills into population, choose individual and access quality of offsprings. Let's see our genetic algorithm refinement process. First one is iterative refinement and chromosome encoding. The initialization create an initialization population of a random solution and fittest evolution calculate the fitness of each solution as we see previous slides. Selection is process based individual for representation and refinement fine tune. Fittest evolution of a genetic algorithm. Fittest evolution guides the algorithm towards the outcomes and evaluator does come each solution is optimal result guides the algorithm towards the outcome. Chromosome represent a potential solution to consist of genes that encode the variable of problems. Fitness score indicates the quality of solution and helps in selecting the best individual for the next generation. Crossover method is single point crossover, two point crossover, and uniform crossover. Combines genetic material at one point and simple and effective. Exchange material between 2 points exchange diversity. Random select genes from parents maximize exploration. Genetic algorithm termination cycle. It contains 3 points. Achieve conversion to stability. Let's see the advantages and disadvantages, pros and cons. Enhance outcomes, simplifies, improve result for strength and optimizing research, increase efficiency, quantitative edges, and motivated workspace, resource intensive, complex implementation, and resistance to change. Resource for learning. These are resources which I used to reduce these podcasts. These are the outcomes of our podcast. These are the questions. So let's conclude. Genetic algorithms are inspired by process of natural selection and evolution. Genetic algorithms are best. Genetic algorithm adapts handling complex, non-linear and multimodal problems. They balance exploration and widely applied in artificial intelligence, engineering, scheduling, and real-world problem solving. Thank you.